All right, last one. Just real quick going over some homework answers. Again, why do Maclaurin series fit their function so well? Okay, I'll stop. Okay, so number one. We did I even do part C? Oh yeah, I did. Okay, so write the first four non-zero terms in the general term for the Taylor series for f about x equals 1. Right, so you slowly had to piece these in together. The key there for me was realizing that this n minus 1 factorial and this n factorial sort of canceled. So it looks like you don't really have a full factorial on the bottom. You shouldn't. Okay, you should end up with something that looks like that. But other than that, that was pretty straightforward. Hopefully for you guys it was too. The Taylor series for f about x equals 1 has a radius of convergence of 2. Right? That means we can just sort of know that is going to happen between -1 and 3. We have to look at the two boundaries. One of them is an alternating series, the other one wasn't. So I got that there was equality at 3 and not at -1. And then for the last one, right, we're just approximating. So we're just shoving in 1.2 in there, and you get whatever this is. I didn't actually evaluate this. I don't know if this is a calculator AP problem or not. I didn't care to evaluate that, but it's whatever that is, that expression that I have down there. It's nothing too much. Again, the things to realize, I think that we had a factorial in the numerator, so the factorial in the denominator sort of canceled in part A. Part B, right, the Taylor series about x equals 1, that 1 is going to be where this interval of convergence is centered. We don't have to do a lot of math for that, and that should make sense, right, that when we do this out, that at x equals 1, all the things are 0, right? So that sort of has to be the default where my series is going to converge, or where that interval is based. Okay, we did 2 together on the screencast. We did 3 previously. 4. Fine. Okay, so this one was a good one that I want to dwell on a little bit. Okay, I didn't show a whole lot of work because I didn't have a whole lot of space, but I do want to talk through this. Okay, so we have e to the negative x over 3. And I know Miss Yam dealt with one of those. If we go back to S1, we remember these guys. And that e to the negative x, right, we were just dropping in negative x, so it made every other term negative, right? It made all the odd ones negative. So coming back over here, right? We're just plugging in negative x over 3 every time we saw an x in our standard e to the x Maclaurin or Taylor series, right? So in that expanded form. So that's what I did here at the bottom, right? The key there was to remember that there's a 6, right? This 6 is sort of external to everything, right? This little 6 right there is external to everything. I multiplied by that at the end. Don't forget about it, but you don't need it at the beginning, right? It's just e to the negative x over 3. Handle that and then multiply by 6. That's sort of what I did there. I got these 4 terms. Nothing too crazy. Okay, the next one, they're asking us to... Oh, sorry, the general term, that was fine too, right? If you got the other 4 terms, the general term wasn't bad. But again, right, focus on that dropping in method where we sort of know those 3 series. We had to drop in negative x over 3 for x. So that made the negative made the terms alternate, and the 3 sort of appeared to the same power that x was, but in the bottom. Okay, so for b, let g be the function given by this accumulation function here. Find the first 4 non-zero terms in the general term for the Taylor series for g about x equals 0. Well, we have f already, so we're just simply integrating that and then plugging x in. All right, so I integrated all my terms from part A. I got these guys, and there's my general term. Okay, so that was for A and B, and then I also wanted us to do 5a and b. 5a and b, just writing the polynomials, just to get that practice and that muscle memory, right? So if we're given this chart, I don't care about 1 and 3 in there. I only care about this row right here, and those are my coefficients, or part of my coefficients. I really should say part of my coefficients, because we still have the factorial that comes in, right? But you see here they just drop in, and you'd plug in 1.9 in there, and presumably this was a calculator question, because I can't imagine having to do this without a well, I guess it's just 0.1, but in any case, this would be a lot of needless algebra if we actually had to come up with an answer without a calculator. But I guess you don't really have to do that. This expression should be fine. All right, so those are my answers for the Taylor homework. I hope you've enjoyed these screencasts. I'm losing my voice right now, but I hope you enjoy the rest of your breaks.